testing how good you are with the mouse. Okay, but ultimately we're going to end up building a custom dashboard where we can display not only the video from the camera, but we could put crosshairs on it to allow us to align with whatever mechanism we're using to launch a projectile. So that in itself is kind of handy, and it broaches some of these other tasks that we've been doing. So I'm going to turn my camera off. You can one of the things that I want to emphasize, so what we did last week was to hook up a servo and then show how to interface with the servo so that it controls something like a camera. Servos are also used for gates, and in the simulator tonight, it's used to actually agitate the hopper and then feed the balls one at a time into the shooting mechanism. So servos are a pretty handy thing to know. Tonight we're going to customize the dashboard. I want to say a couple of words about sensors. My all-time favorite sensor is the encoder, and the second one is a gyro, because with these two elements you can pretty much do a dead reckoning command set for the robot and be within 10% of where you think where it needs to be once you've been able to master the encoder control and the gyro. So unfortunately, in the simulators they don't have encoders, so I'm just going to walk through that next time to show you how to set it up, and we'll discuss it a little bit more. I want to kind of reiterate that in all designs that I do, I make sure that all my signals go through Robot Global Data, and you'll see in the simulator tonight that they don't write everything there, but they use it to a fair advantage in being able to move the data around the program. In addition, once we get the robot made, constructed, and then the program installed in it, we don't have things like probes to be able to look at the workings of the program itself. And so what we have is a list of variables in the dashboard that will give us a clue as to maybe what's going on or what's working or not working. But you have to write those variables to the dashboard as you're building the program. So that's something you'll see, and I'll show you how it's done and where it shows up. There is a gyro in the simulator we're going to use tonight, and so what I'm going to show is how to hook it up to the front panel so it can be used by the driver. And we're going to be running both the dashboard and the simulator in LabVIEW at the same time, which is a fairly amazing trick considering how limited computers have been in the past, but it kind of lets you know where we are today. So we're going to create a new project, and so I'm just going to walk through this and then everybody can follow me as I actually do it. So we're going to develop a new project called SimShooter. It's one that's built in, and although I don't fully understand the design principle, it's kind of clever to see what they've done. And I'm going to walk through the begin and finish that they've set up, show where they're reading and storing the data and periodic task, and then how they write the data to the dashboard using the smart dashboard write function. Then we're going to, another hint is once you put the program in Flash and you set the robot aside for a couple weeks and you've made changes to your program without updating the Flash, you may forget what program was loaded, what version of the program was loaded. And so one of the things that I put on the variable list is the program name so that you can correlate historically what was been loaded and you don't have to kind of reinvent the wheel. Okay, so let's do this. Everybody want to open up LabVIEW, and we're going to create a new robot project. I'll be there in a second. Okay. So this is going to be a new FRC RoboReel project. Need to put in the title, make it 2021 Sim Shoot. And spelling doesn't count because you're the only one that's going to see it. Put your team number in there and select Learn LabVIEW Ball Shooter Simulation as the model that we're going to build from. Click Finish. Now again, we're only going to make modest changes. Those of you that have a joystick, this is the one time when there's going to be an advantage to having the joystick. And if anyone doesn't have a joystick, I remind you can go back and simulate controls from the dashboard after we get the program built. So I apologize in advance that you need a joystick for this exercise. Okay, it's taking its sweet time. All right, now what I want to do first is just look at some of this code. So I'm not going to change it. I just want you to see where they've put their design. So I'm going to open up begin.vi. Again, all the code changes, or all the team code is built in this team code area. But even though you can find it with the Project Explorer and the File Explorer, make sure you open up the project first before you start making changes to the code, because as long as I do them from the Project Explorer reference, the connections are made between the various VIs. So we're going to look at the block diagram, and you can see that they've got a 2-motor drive system. They're using a single USB for something. They've got 2 motors over here to control the shooter. They've got a single servo to launch or release balls into the shooter itself. They have another servo that agitates the hopper. We'll see this in action. Here's where they set up the gyro. And again, if you look at the tutorial for simulation, it tells us to use the A1 analog input for the gyro. Here's another motor controller that's the right intake and the left intake. So these are in conjunction with the spinner. Now these icons here, so any questions about opening up the channel and assigning the reference name, that's what this is all about. These icons over here that say NT and then show a pencil, these are a write. In this case, it's a Boolean, which we can verify by the fact that there's a Boolean signal going into it. And they're writing to that list, and then storing it under a name called shooter switch. And we'll see where that shows up later on in the discussion. Then here's a numeric value that they're writing to the smart dashboard, the agitator speed, I guess, and then the scoop speed. So again, this is all in begin, and it's kind of fun to watch.
Why are some of them in a box? Why are some in a box and others are not?
Well, because they're associated with the dashboard controls. Usually you don't do this kind of stuff, and so they made a note to themselves as to why they did it. This is what a normal begin looks like. This, they're setting up the dashboard conditions because they have a special dashboard that you use in conjunction with this. Another point
so the box doesn't really do anything.
No, it's just notes. It's just annotation.
For the benefit of the viewer.
Yeah, a reminder to the guy that wrote the program why he did this. Now, here's a good point to be made. You'll notice one of these motors is inverted over the other, and this is due to the fact that we're driving a similar motor, but one's mounted on the left side and one's on the right, so they have to run opposite of each other to be able to go the same direction. And that's A word to the wise. Okay, so that's begin. Now, just out of curiosity, I want to look to see how many they've closed and finished, because I insist that you got to close them all, and they don't. Again, I think that's a function of the fact that this is a simulator and there's not much downside to having code floating around in the RoboRio. Let's look at periodic task. Now here you can see they put a lot of, they don't have anything in their 10 millisecond task, and they put a lot of code with some fancy math looking functions in the 100 millisecond. In fact, they don't even put a time element in this one, which kind of amuses me. It's called 100 millisecond, but they took the time wait out, and it could be because they have so much logic in here. Here's your dead zone, I think. No, this is something different. This is the joystick. I don't know what it's doing. That's part of this, the test, to see if you can figure out why they're doing this. So here they're right. Here's the channel coming in for the two motors for the intake, and they have to be running opposite directions, but they're not showing us. Well, here it is right here. They're multiplying by a negative value, and so this is what's inverting the motor drive. This is the sonar, where they're measuring the distance to the target or the wall. Here's the gyro. The gyro puts out a signal that goes plus and minus 180 degrees. And so they convert the fact that it doesn't go full 360 with this kind of clever little contraption. But when they write it to the dashboard, that's what this is a write to the network tables is what NT stands for. They use the term orientation. So if we're going to pick this up in the dashboard itself, we need to use this channel name. Okay, so I'm leaving most of this up to the eye of the beholder to figure out what's going on, because I don't totally understand all of it. And it's written, it may be worth going over the tutorial to explain it. I do want to do two things. I want to set up a write. Let's do this again. I want to write to the dashboard the name of my program itself. So that's under network tables, pin it. So I'm going to write a value. It's going to be a string value. And the name of the value, right click and enter a constant, is program name. And now the program name is going to be a string that I enter down here, the string value, and it's going to be, let's call it SimShot dashboard. So again, this is for posterity's sake, and I want to be able to look at the dashboard as I'm driving the robot and understand what version of my program that we put in there. So the two things that are going, this is going to the dashboard, and then I want to keep track of the orientation of the gyro. Any questions? So what we've done so far? We haven't done anything except add one line.
Jim, where did you find that menu of icons?
Right click. So it's under the WPI robotics library. Pin it so you can look around. It's under the dashboard palette down here. NT stands for network tables, and it opens up into this scheme. And the two main icons we use, the glasses are for reading and the pencil is for writing. You see it?
Sorry. Every time I open our menu system, the text labels are gone, and I always have to go back under customize and tell it to add the text labels. I don't know why I can't remember.
I don't either. unless you're not safe. I can't. We're going to change that in a little bit anyway.
It's really hard to find your way through those menus, text
Right.
labels.
And that's part of what the exercises have been, is to just scan some of them and recognize the terms that are used. Okay, so any other questions on what we just did? Putting in this right program name, right string. Doesn't matter what these are, you'll see where it shows up in the dashboard. Everybody there? So,
sorry, Jim, one more time.
That's
what
all right.
menu was that? WPI robotics library, then dashboard, then what?
Dashboard. And you got to pull it up off the screen. And it's the right value.
Oh, right.
So there's the two main icons we use are write value and read value. You write value to put numbers into the network table, and then you read them to get them out. And we just want to write a string. The name that goes on the top is the program name, and then the actual name itself is whatever you put in the second string. Okay?
Okay, we got it.
All right. Now, I'm just going to minimize this, close and save the periodic task, close and save, finish. I want to go back to robot main in this project. Double click on it. Here's where we're going to enable the video. So I'm in the robot main front panel, go to the window and show block diagram. Everybody on the block diagram for robot main? Anybody not? All right, there's two blocks down here that show they're disabled. I'm going to right click on the edge and remove diagram disable structure on both of them. Right click, remove diagram disable structure. And it should look like this when you're done. Everybody get that? I'm going to go back to the front panel and I'm going to run it with the white run arrow. And I get my simulator window. I'm going to minimize this. I'm going to turn on the zoom and zoom in a little bit. And there's what the robot looks like. And the fact that the balls are jumping around is the function of the agitator to keep the balls from getting stuck. Okay, while that's going on, watch how I do this. I want to go to the front panel of my robot main, go to view, left click, and then click on the getting started window. It brings us back to the getting started window. Everybody ready? Anybody not here? Anybody totally lost? Okay, we're going to start a new FRC dashboard project. Left click on FRC dashboard project. Give it a name, call it 2021 SimShot dash. And it's going to be a straight up dashboard, the first selection down below. And click finish. Anybody not here? Okay.
Sir, can you wait up a bit? Mine is still loading.
Which part? Your dashboard?
Trying to get to that panel.
Okay,
Like the project is configuring.
sounds good. Now, you'll notice that we don't have team code in the list. All we have is dashboard main. Did it configure or did it set up?
Yes.
Okay, double click on dashboard main to open up the VI. Now this is the front panel. Don't change anything because this is the dashboard itself. Go to Window, Show Block Diagram, and this is what's going on behind the scenes in the dashboard. You scroll down just a little bit. What this structure does is it multiplexes the data that's coming off the channel from the driver station. And so on certain frames, it's going to be spitting out joystick data, motor data, and other things we have stuck, the system sticks in there. One of the things we want to catch is that the thing that's connected to the gyro. This little icon down on the bottom right-hand corner it's labeled gyro, and because there's a pimple on the left-hand side, we know it's an indicator. If you right-click on it and say Find Indicator, it takes you to the front panel and shows the gyro shape that's on the front panel. So if I go back to the block diagram, this is the indicator that's on the front panel. We need to read from the variable list that channel that they call orientation, and we need to feed it into this indicator marked gyro. So I'm going to right click, go down to WPI Robotics Library, go to the network table dashboard, and pull out the read icon and put it right there. Now we're not reading a Boolean, we're reading a numeric. So we use a white knuckle to pull this down to read number. The name of the number again is orientation, so I right click and create a constant. And now I spell orientation just the way it was written in the program, O-R-I-E-N-T-A. Okay, so if I don't spell it or if I don't get the case right, it won't make the connection, but it looks like I'm close. Then I take the numeric signal out of the right-hand side of this read icon, spool a wire, left click, and connect it to the gyro. So what this is going to do is take the data that we're putting in the program for the robot under the label orientation, and it's going to read it out and deliver it to the gyro. Anybody have a question about that, or have you been able to make that setup?
I was not able to find the network tab. Where was that?
Okay. It's a dashboard tab, it's not network. It's NT for network table. You right click, WPI Robotics Library, pin it so you can look around. Dashboard has NT on it, click that. And we want to use the read icon. Did you find it?
Yeah, I was just mainly listening to what you were saying and following along, so I didn't make the connection between dashboard and.
Yeah.
Thank you.
So I was mixing up my nomenclature there. Okay. All right. So this is going to deliver the value of the gyro to our dashboard. If you scroll down to the next set of while loops, so this is a while loop, and we're not going to go through all the setup, but basically this is a channel that delivers the image from the cameras on the robot to the camera display on the the video display on the dashboard. And what we're going to do is put a crosshairs on the dashboard, and I sent everybody a screenshot. Here's where you need to follow along with me. So, okay, first of all, we need to open up an extra palette. If I right click and pin it and customize and change visible palettes, the palette that we want to add to our list is the vision in motion. All right. And then we click OK. Now, when we open up the palette, we have vision in motion, and we're going to look up vision utilities. Everybody get there? So we've added vision in motion to our list of palettes that are available. We've opened up vision utilities, and what we're looking for is overlay. And open up the overlay. Everybody follow that? Anybody not be able to follow it? So what we're going to do is put two rectangles. So in my case, it's the second row on the left, the iMac overlay rectangle. I'm going to click it once, put the rectangle icon there, click it once and put the second one right here. Then I'm going to close the palette. I'm going to get rid of this note. Okay, everybody with me? That wants to be with me? I'm going to go up to Context Help, hover over that icon, and I can see that there's a significant construction. The image goes in the top left, comes out the top right. So I'm going to take the spool of wire down to my image pipe, it's called, and connect it to the input of the top left side of the first icon. And then output from the right side image out to image on the second one. Now we're not going to connect it down to the camera image yet. Okay, the second pimple on the left says rectangle. I'm going to right click and create a constant, and it gives us 4 variables, 4 parameters. And if we look at the detailed help, as I scroll through each one of these, the top one is the left corner, the left dimension of the rectangle. The next one is the top. The next one is the right coordinates. And so these are the numbers that are going to define the rectangle. In this case, this is a horizontal rectangle. So I'm going to put in a note that says horizontal rectangle. And over the other one, I'm going to say vertical rectangle. And I'm going to create the constant here. Okay. At this point, is everybody ready to enter numbers? Where'd we lose you? Okay, the numbers on the left for the horizontal rectangle, double click on it. The first number is 100. Double click on the second one, number's 80. Double click on the third one, the number's 160. And then double click on the last one, the number I have is 90. Now, I'll explain this in a second. Let's go ahead and do the vertical rectangle. Double click on the first top number. Number enters 125. Double click on the second one. Number to enter is 60. Double click on the third one. Number's 135. And then double click on the last one. And the number's 110. Okay, so this is going to define a rectangle. The coordinates for the video start at 0, 0 in the top left-hand corner, and then proceed down horizontally and vertically to the maximum dimension, which I think is 640 by 240. We'll see it when we look at the camera. So at this point, I'm ready to tie this rectangle overlay back into the image. So I'm going to select the image pipe and delete it, and connect the image out to the image display. And so it should look like the attachment I sent on an email yesterday. Is anybody trying to follow and not there, or just want to see me go ahead and? Yes.
I'm following.
Okay. Anybody else following and need some more time? Are we all on the same page? Okay, so what we've got now is a modified dashboard. We're going to come back and minimize this. Now, before I do anything else, so this is still the front panel of the dashboard that's not running yet. I want to open my driver station. So left click, open the driver station, let it do its thing. In my case, it opens up the lower panel, which is the driver station itself. And then because I have the setup on default, it puts up a dashboard that looks like this and requires access. Okay, so watch what happens now. Right now, this dashboard is being designated by the default selector. I'm going to turn it off to this existing dashboard. I'm going to set it to LabVIEW down here on the driver station, and then I'm going to run the dashboard that we have the modifications to. So yeah, did everybody catch that? Anybody not be able to do that? It's a little bit of a tricky thing, and we'll come back and do it a couple times after I show the net result. Okay, so the thing I want to do right now is come up to my operator tab on the driver station. I want to come back to my display screen for the simulator. I want to close it off or stop it. And then I'm going to rerun it. And what I want to see is this green light come on, which shows that I have connections to my network table with the dashboard. You see my green light came on the dashboard. Okay, so here's where things get kind of neat. So I'm going to zoom in on my robot. I can look at the camera. You can see my crosshairs have been put on the screen. I'm going to enable the driver station down here on the bottom left and teleop. And now as I go back and look at my dashboard and I move the robot around, you can see the gyro changing and the video changing. Anybody impressed?
I'm definitely impressed, but I'm not able to get my dashboard to come alive.
Okay. Well,
what might I be doing wrong?
Well, for starters, you need to have your setup selecting LabVIEW, right? At that point, have you run your dashboard program, the arrow on the front panel of the dashboard?
Okay. I thought I did, but maybe I didn't.
And you need to So if you're showing, if you're connected, you have the ability to select a camera from the video, from the image. And if you're not connected, stop your simulator with the close button and restart it. You want to show me your screen?
I've got two screens going. I don't. Oh yeah, I guess you can see. Okay. Okay, so here's my screen.
Okay. So let me see the front panel of the dashboard.
Here's the block diagram of the dashboard. There's the front panel.
No, that's the block right there. Okay. Now see, you've got it. So you should be able to select the camera selection over below it. Yep.
Oh, okay. Now, when I was doing this before, it wasn't giving me a camera to select.
Right.
Okay, now
your
it's
green light wasn't on. The network connection wasn't made. It looks good. Now as you move your robot, move the joystick, it'll start to turn the robot and your gyro should indicate. There you go.
Okay, good. All right, great. Thank
Now,
you.
Yeah. Anybody else?
Sir.
Yeah.
So you said to go to the settings and the dashboard type to switch it to LabVIEW from default, right?
Right.
So I did that, but it took out the gyro page thingy.
Show me your screen.
Okay.
Hate it when it does that.
Can you see my screen?
I can. All right. Where's
You
the?
can?
Yeah, I can see it.
Oh, okay.
So where is your dashboard program?
So wait, where is it? Not that one.
Yeah, that was it.
This one?
No, the one next to it, right there.
That one.
Yeah, open up the dashboard.
Oh, there you go.
Okay, now run it with the white arrow.
So this one over here?
Yep. And see your little green light isn't coming on yet? Hold on. So then go over to your simulator and close the simulator with the close button at the bottom right.
Uh-huh.
And give it a chance to resync and then start it again. You need your robot main. Go back down to your menu bar at the bottom.
This one?
No, the front panel.
That one.
Yeah. Now run it.
And so run it would be this button, right?
Correct. And watch your green light's on. Now you can select your camera over on the dashboard.
So this one?
No, well you can, but it's not in that panel. Go on the left. Yep.
That one.
You got more cameras than the rest of us. Good job.
Oh, which one would I choose though?
Pick them all until you find the right one. There you go. Pick the camera. That's it. There you go.
Oh,
hey, and your Graticule looks good. Now, do you have a stick, a joystick?
No, I do not.
Okay, well, so your challenge is going to be go into the teleop and be able to control the motors with the slider and the buttons that we worked on two classes ago, and you'll be able to see the gyro follow the motion of the robot.
So teleop, does that mean that this needs to say teleoperated enabled?
Yes.
Okay, so would that be like over here?
Yes. Now, so that turns on the motors, but you have to have a joystick to control it.
Right.
So you need to work on the joystick simulator part that we did 2 classes ago. But you did everything else perfectly.
Okay. So that I'd just be like stuck here since I don't have a joystick?
No. Look at also where you're there. See the right-hand corner on the dashboard says variables? Click on the variables. Now these are all the variables that we wrote to the dashboard. And if we look at the DB, expand the DB,
This one?
Yep.
Whoa.
All right. Now scroll down. There, oh, not so far. Just to the bottom of that first, go a little bit farther up. Right there. See where you got your name of your program is SimShot dashboard,
Yes.
right? That's due to that one string that you wrote in your simulator program. The orientation is the gyro angle, right?
Yes.
There's your, now, these others are the other data that they were writing to the dashboard. So when we write to a dashboard, they all get listed under this list of variables. And so now by manipulating your control system, you can find out what's working and what's not working in your program, even though you don't have access to the program itself. Does that make sense?
Yeah, a little bit.
It would make more sense if you wrote the program, but for some reason, the guy that wrote this program wanted to see all these different variables while his robot was running. And that's what this allows us to do. Now,
Okay.
just because you're there, on the top row, the second tab says camera. You can now select the second camera view from the list down below.
So that one?
Yep. Now that's going to be the same view you're seeing, but it's the one that doesn't have the crosshairs on it. Now you notice, I don't even know where the camera is on this robot. I don't see one. If you look at the driver's view
Here?
on the simulator, yeah. So this is allowing you to look at the wall where you need to launch the balls. And for those of you that want to dig into this further, reading the simulator README list will describe not only how you can control the robot, but there's a special shooter dashboard that displays all this information on the front panel itself, and it looks different from a LabVIEW dashboard. That's the point. The thing we're trying to illustrate is how much you can customize the display to give the driver more information than he can see from the edge of the field, because you're looking right down the pipe of the robot itself. Any questions from anybody else? You did a good job. Anybody else having trouble? Yeah. Well, and the idea is to think in terms of when you're writing the program, what variables would be useful for the driver. And like I say, if you have an encoder and you have a gyro, you can pretty much have that robot follow any path you want without being able to see it. And well, that's what we'll do in autonomous next week. Okay, so what have we learned? Any questions from anybody else? The one drawback, I guess, that I would mention is the bandwidth of the RoboRio is limited when it comes to image processing. So what we've done here is we haven't really taxed the camera and image processing on the robot itself. What we've done is put a crosshairs in the video stream of the dashboard, and it doesn't take that much overhead as far as bandwidth. And so once you get into actually building a robot, you probably want to explore an off-board camera, and there's several out there that do a nice job of being able to match up and just feed the data and the image from a separate processor. But I don't have one of those on this particular robot. Okay, anybody else having problems and want to show me what their screen looks like? I think we only got a couple people. Anybody else totally lost? Okay, I think that's all I had tonight. The main part I was trying to get across was exactly what we did, which was play with. Now, here's a suggestion for homework. Go in and play with these numbers. The purpose of a crosshair is not to show me the middle of the screen, it's to show me where I have a target lined up that my shooting mechanism will fire and hit that point. So what I think is a worthwhile talent or skill is be able to put this crosshairs any place on the screen and then think in terms of aligning my shooter with wherever that's. In other words, I position the robot in a certain spot, fire the frisbee, and wherever it hits, that's where I want to put my crosshairs so I know I can dependably hit that spot. So what I would suggest is to play with the numbers in these two rectangles and see where it puts this crosshair on your display. And the reason we're going through all this is you need a video stream from one of the simulators to be able to put crosshairs on the video. Okay, any other questions? I think that's all I wanted to present.
I've been trying to shoot some balls, and I pushed every button there is to push, and nothing shoots.
Yeah, well,
you know offhand what?
No, I haven't taken the time.
Is that part of the code disabled? Maybe.
No, it's not disabled.
Okay, I'll play with it.
Well, there is a README, and there is a special dashboard that you control some of those features with. So it's worth using that. I think you control the speed of the launch motors from the dashboard. It's a pretty clever design, but like I say, I haven't taken the time to really understand it. And that's kind of the way that one of the things.
Okay, I'll look at the reading.
Yeah, one of the things I love about FRC is they give you a lot of clues and not necessarily all the pat answers. And so as you're digging into it, you learn more as a result and can gain more than just how to run the video game, how to actually make the thing work behind the scenes. Okay, anybody else? It seems like we had somebody that wanted to work through their issues with Eric.
Yeah.
So so tell me what your problem is. That your loading LabVIEWs is an issue?
Can I share my screen and show you?
Yes.
Okay.
So I'm gonna go ahead and turn the camera off unless anybody, not the camera, but the record.